what is the scale we are talking about when we are using ENVI-met. And then we'll also try to understand a little bit on urban physics. That is essential. So the more understanding that we have on the fundamentals, the appropriate questions or the pertinent questions that is relevant, we'll be able to answer. Okay. And then I'll also highlight um, one of the commonly studied work is on urban thermal comfort studies, outdoor thermal comfort studies. What are the basics fundamentals that is required, and what are the inbuilt analysis that is there in ENVI-met. We'll also try to understand how we can generate that, and what are the fundamentals that goes in the conceptualization part. Apart from this, apart from tool, we should also have a conceptual understanding on how do we understand the subject from the research perspective. How do you set up the data? What kind of data is required? How do you collect it? And how do you bring it to the tool and then analyze it? Okay, so we'll try to understand what are the different tools also available, instruments that we can use, and also some of the data set that is freely available as well, especially with respect to climate, how we can bring that into the tool, and then we'll try to understand those aspects as well. Okay, so like I said, this is not only about tool. Okay, we'll also discuss the concept simultaneously. For tool, I think maybe just 2-3 hours of introduction is more than good enough for us to run the simulation. Okay, and the ENVI-met, I'll also show you the platform where they have the software. The company themselves have a pre-recorded tutorials on how do we run it. Okay, so it's not only about tool. So let's take this workshop a little more than that. So that's the intention. Okay, so urban climate research. Okay, normally what we try to do, we try to understand how we can bring or how we can relate urban areas with the environmental parameters. Okay, particularly the temperature, humidity, precipitations, and radiations, and so on and so forth. So what is this link that the urban environment have this environmental with environmental parameters? Okay, normally this is done at two levels. One at macro level, where we try to understand how the large settings, for example, the mountains or the water bodies in the city or the big forest lands, what is the impact of these natural settings on the environment. And the second aspect is where we are trying to focus more on urban microclimate, where we try to understand how building geometry or the height of the building, vegetation, or the water body, or even the orientation, does it have an impact on how the building is performing, or does it make any sense to study all this? Okay, so our focus will be more on this, on how do we understand this. So we are trying to use these tools in line with these urban microclimate studies or urban microclimate research. Okay, that's the first point. The second point is, I think I'm better like this. Okay, the second point is, if you look at the urban climate per se, one of the common thing that is discussed is something called UHIs, urban heat islands. Okay, and I think in one of the speaker here also said that becomes very relevant. It has to be studied because we are growing, and as the city grows and more buildings are coming up, more vehicles are coming up, and the heat gets retained in the city. Okay, that's the very general concept that we have with respect to the urban heat island. Okay, but if you look at the concept, what is it about? If you see here, so we have the city. Okay, as we go towards the city, okay, more heat hotspots or heat accumulation happens because of the intense activity, accumulation of built up, and so on and so forth, and so and the activities that happens in the city. Okay, so this is the first one. If you look at the theoretical aspect, we call this as urban boundary layers. Okay, But again, this is a bigger scale. We will not be discussing about urban boundary layer conditions. Maybe, for example, let's say city planners who want to study the entire city and then come out with some kind of intervention. Maybe, for example, let's say blue-green infrastructure as a measure for mitigating UHI. So for those aspects, the urban boundary layer conditions can be studied, and it will be pertinent to that. Rural boundary layer again in on the other side, that also we will not be discussing now. What we'll be trying to discuss is the urban canopy layers. So what are urban canopy layers? So now we are using a new word, canopy, here. So how do you understand canopy? For example, let's say if you take one part of the city here, that one part of the city is blown up here. You can see, so we have buildings, we have vegetations, and then we have streets, narrow streets, wider streets, paved, unpaved streets. So this is one canopy for us. Okay, so so it's not the entire city as such, but it is a part of the city. It can be a small neighborhood, it can be a street also. I'll show both. We'll try to understand both examples as well. How we can use this tool to understand a neighborhood with multiple streets. And we can also do this kind of study in a one single street also. I'll show some case studies at the third day where we have applied this in several streets, and then what kind of interventions that can be drawn using this. We can also further go down to understand what happens to the building and the immediate context of the building, where primarily we, as architects, we are more interested in. This is our building, and what is the impact, the immediate impact of this building, or the immediate surroundings and its impact on the building. This can also be studied in ENVI-met. I'll show some relevant results on these lines. Okay, so why am I highlighting all this? Is the tool will generate result. Okay, like I'm telling you, just 2 days is good enough for generating results. But to coming up with appropriate question is the most challenging thing. Okay, so whether your question is at building level, whether your question is at street level, or whether your question is in the entire neighborhood level, it all comes from your question. Okay, so this is something that we should have and keep this in mind when we go further on this. Okay, I'll skip these theory part. There are more things that gets into picture. For example, let's say there's something called roughness layers. We will come back to all these wordings when we use the tool, when we use the tools as well. Okay, this is a second point. Scale of the study has to be understood. The third point that we should also remember is from the climate perspective, we normally use certain scales as well. We call it as micro scale, local scale, or the meso scale. Micro, local, and meso scale. Micro scale is a scale which is building and the immediate context of the building. Maybe let's say if we are interested in understanding what is the heat balance that is taking between the walls. Okay, so that's very microclimate issue. Or maybe we are trying to create some kind of shading elements in the building, and then we wanted to understand what is the impact it is creating. So this is very at micro level. Or maybe let's say we are trying to put some pavements, cool pavements, and then we wanted to check what is the impact it's creating on the indoor condition. Okay, these are very microclimate level. The second scale is the local scale, where we are trying to understand whether, let's say, if you take away all the streets and then we do cool pavements in the entire neighborhood, does it make any difference? Okay, so it's not now one building. Now it is slightly extended portion. Maybe it's a neighborhood, or maybe it's a cluster of urban areas. Okay, so this is the second scale that ENVI-met is designed to give answers to these scales. Okay, these two scales will be able to answer, or will be able to generate more meaningful output for these two scales. Okay, so this is a simple summary of what all things can be done and what are the different scales and how it can be studied. We'll go from the bottom. We have something called a regional level or city level, or where the study is more about the entire entire setting itself. Okay, that's where we have something called urban heat island at a macro level that we have. Okay, ENVI-met is not designed for this. Let's not have any questions on can we use this tool for understand heat island in a city level? No, we can't do that. The scale is not designed. The tool is not designed to address this scale. Okay, where we should be going to GIS and other platforms to extract heat islands for a city level issue. Okay, what the tool can give? The tool can give assessment of neighborhood level. Okay, we call it as local climate zone, or it can give it can simulate or will be able to generate results at block level, which is 0.5 kilometers by 0.5 500 meters by 500 meter grid, or a canyon or a street level, which is about maybe the width of the street and the length of the street. Okay, so or we can also try to understand what is the impact of some facade change. All that can also be checked here. So this is a good reference material to understand what are the scales, what are different scales, and how we can use these scales to come out with appropriate questions, parameters for assessment, and also choice of tools as well. Okay, this is point number 2 that we should remember in this case. Yeah. Yeah. ENVI-met is suitable for yeah. ENVI-met. No. We can't do this city level. We can do. It will give more appropriate results at this level, block level. 500 meter by 500 meter. It means 500 by 500. Grids. Such kind of grid you can. We can do. Yeah, yeah. It can give you more correct answers for these kind of models, not bigger models. We can in fact generate more 1 kilometer by 1 kilometer also, but it may take months for simulations, and it doesn't make sense also to do that. So we can use ENVI-met primarily to address or study something of this scale, or maybe street scale, smaller than this. Yeah. Okay. Third point that we should remember, or we should have an understanding on when we before using the tool, is to have an understanding on what is what are urban morphology, what are the parameters that defines urban morphology, because we are going to use this. Okay, for example, let's say if you don't know what is height to width ratio, sky view factor, canyon access orientations, will not be able to comment on what are the parameters we should tweak in order to get an optimized output. Okay, so for example, let's say if we say that the aspect ratio of the street has to be more or less, how do we say that? Okay, the system will generate result. It will generate result for maybe 3 meters. It will generate results for 30 meters also. But how do we say that 30-meter wide road is good or 3-meter wide road is required here? Okay, so that understanding is required. Unless we have that understanding, we'll not be able to again have a correlation with the results the tools are going to generate. The other thing that we should also remember is a lot of thing is about surfaces. Okay, surfaces at 2D, surfaces at 3D. Okay, albedo values, for example, let's say your the street surfaces, the building surfaces, and also in ENVI-met we can also bring in the other surfaces, for example, let's say shading or maybe temporary structures and so on and so forth as well. Okay, so this is also essential. We should have a good understanding about all these urban morphological parameters and also the surface level albedo parameters. In addition to that, normally when we talk about cooling or the cooling strategies for any heat island issue, what is that comes into picture? We normally say green will help or water bodies can help. Yeah. So if you discuss the from the planning perspective, most commonly the most common strategies that is presented is how do we do greening of city? How do we bring water body for cooling down the cities? Okay, so this can be done at a macro level, city level as well. This can also be done at a micro level as well. For example, let's say if there is a fountain in a let's say campus, does it help or not? Okay, I'll show you one case study in that we are an ongoing project. We are trying to do an intervention in city of Hyderabad, where we found that during the summer months, the relative humidity goes way below 15%, 22, way below 15%. So in that case, what we need is we need little more humidity into the air. We should add little more humidity to the air. Okay, so how do we say that by having these fountains, humidity can be improved? By having vegetation, can we improve humidity? Okay, so we can try that. I'll also show some results in this line. And the last point, or last understanding, is ventilation. Okay. Any question? That's unmute.
For example, you're talking about the fountain. So, is there anything, for example, if water is moving vertically also, so we do consider that aspect also, or we consider the horizontal aspect, how much area is there for the water fountains?
From the tool perspective, it uses as a point. It's a point data. We can keep it at certain level, and it has a spread, 1.5 meters spread. So it is a two-dimensional. In fact, the entire tool itself is grid based. So it has a range. We can set, let's say, fountain at 1.5 meters. We can keep that, and it has a range. So it can give it to an extent of maybe 1.5 meters, 2 meters, 2.5 meters. Yeah. Okay. So I'll not go into details, but I think we need an understanding. I'm again emphasizing on the need for having a thorough understanding on what are these concepts, because these concepts only, through these concepts only, we'll be able to ask pertinent questions. As simple as that. For example, let's say if you want to change the roof property, okay, you want to add green roof. Okay, so what parameters you have to change, and what is the logic for going for green roof or cool roof, and how do we change it? Yeah, so we need to have an understanding on the building point. Okay, so with respect to building, understanding the aspect ratios. Okay, whether we need a narrow street or wider street, and also in which conditions during summer months. How is it going to behave during winter months? How is it going to behave? These questions can be asked thoroughly. Can be asked when we will be able to generate meaningful results into it. And also we should have an understanding on the sky view factor. Sky view factor is from the urban climate perspective, or from the climate perspective as such. The more sky we have, the easier it is to dissipate the heat. Okay, in a very simple way, if you have to say. So how much of sky is visible can give a lot of answer on how much heat is going to be trapped or not trapped. Okay. So we will be able to generate sky view factor results as well in the tool. I'll also show when we do the model. These are outputs that can be generated directly in the tool itself. Of course, orientation, I don't have to emphasize. This is the first step that we always try to do to understand what is the orientation, and whether at neighborhood level or the context level also does orientation play any role in this. Okay, and the last with respect to the materials, we should have an understanding on what kind of materials to be used. Okay, so if it is the ground, what are the albedo values? If it is vegetation, what are the albedo values for the vegetation, water bodies, and so on and so forth. Yeah, similarly for roads, asphalts, and other aspects as well. we will have one session exclusive discussion on how do we generate our own materials, okay, for model. Okay, that will be the in fact first discussion on how we have to make catalog of materials before we actually go into tools. So for that, we need to have an understanding on what are what are the reflective values, U values, R values of these materials as well. Then the vegetation part, okay, especially for the landscape architects, the tools give extensive modeling opportunity. Many times people come and ask me, can we make realistic? They go to site and they have a tree, they have some vegetation map, and they want to recreate those models in a virtual way and test it. Okay, so can we do that? The tool gives a lot of flexibility for modeling the trees to a, in fact, large in a very detailed manner. Okay, so you can check that as well. Water at the moment, they have only two properties. One, we can use it as a fountain, and the other one as a surface. Okay, I think in the recent version they have added one more layer. We'll check when we go to that aspect. We can also model, or we can also check what is the impact of water and how to what extent it can give some results. Okay, so I've just put a lot of other details, which I'm not going into details. What I'm trying to say is, when we say I'm going to use water, we should know what is it, the thermal conductivity of water, what is the albedo properties of the water, what is the depth of the water, whether shape of the water body, shape of the green play a role. Okay, so these fundamentals the tool will not give. We should have an understanding on. Only then we'll be able to make a correct judgment on this. Of course, wind, we'll be able to generate, or we'll be able to do simulations on wind as well. We'll be able to understand how wind patterns are occur and how it can be moderated as well. Okay, so these things are essential. Just to put it in a summary, the urban morphological parameters, the surface layer parameters, vegetation, water, and airflow. Okay, conceptual understanding is very much essential to do this. Okay, now the question is why we are why this subject is important, and why we have to go into that depth. Uh, um, does it make really does it make sense to go into those details? What are we going to get by doing this exercise? Okay, for example, let's say you have the graph here. You can see this is a daytime temperature for a city, and this is nighttime temperature for a city. Okay, so during the daytime temperature, you can see the ambient temperature is more or less same throughout. Okay, not much variation in the ambient temperature. Whereas if you see the surface temperature, okay, it is slightly higher here, you can see, and also you can see there is a high, there is low, there's again high, and it reaches peak and then it goes down. Okay, why the surface temperature variation occurs, or why we are able to observe, or why we are able to measure variations in surface temperature is because of the kind of urban surfaces that we have here. Okay, so you can see water greeneries, what is the impact it is going to create on the surface temperature. And if you have a greenery and some building, what is the impact it is going to create. And if you actually see, you have a water body here, you can see that your surface temperature and the ambient temperature is same in on the water bodies, okay, during the daytime. So so there is a variation in the surface temperature being created as a result of this. So let us this understanding is required. Okay, only then we'll be able to model and we'll be able to understand why we are making these kind of specific questions, and what is the intervention that we'll be able to observe here. Okay, and the other thing you can see here, this is during the nighttime temperature, where you can see your surface temperature and ambient temperature are more or less same, not much of the variation. Only in the water bodies where it was equal in the daytime, it has shot up during the nighttime. Okay, why? Whatever heat that has retained during the daytime, it has radiating. It has started radiating back. Okay, so these understandings are required. Okay, thus again, those without these fundamentals, we will not be able to make any interpretations of the results. Okay, that's the most challenging part of using the tool. Okay, so if we have understanding of all this, we normally come out with some kind of interventions of using green infrastructure, using green wall, green roof, or water bodies, and so on and so forth. There are so many interventions that can be done from micro level to macro level. We'll have a discussion on through case studies. I'll explain some of it, how it can be done in maybe tomorrow or day after part of it. Okay, so that is the fundamental thing that I have kept for day one with respect to the theory part. Okay, so now what we'll do is we'll go into the tool part as well. What are things that can be done for the day? Okay, so let's start with this. I put some slides. I'll just show the slides first, and then we'll go to the resources as well. Okay, first one, directly, what are things that can be done in ENVI-met? I'll show the links. I'll show the resources from where I have obtained all this, and you can also go through these websites for more insights about what we can do. Okay, what ENVI-met can do? ENVI-met can do solar analysis. We'll be able to analyze three-dimensional solar analysis. Of course, this can be done in other tools as well, but I'm just telling you these outputs can also be generated. Okay, the second point, we can also generate reflections. For example, let's say if you use some specific material on the facade and wanted to check what is the impact it is going to create on the immediate context. Can we do it? Yes. For example, let's say the tool gives a flexibility to divide this 3-meter wall into 20 centimeters grid or 50 centimeters grid. And then we'll be able to analyze 50 centimeter grid as well. What is the impact, whether it is going to create? Yeah. So this one of the output that we will be able to generate is solar analysis. Of course, wind can be studied both horizontally and three-dimensionally. We will be able to simulate humidity part by adding green or by adding water bodies. Does the environment gets the humidity part as well? Then we'll be able to understand at further specific levels, like what is the temperature, surface temperature at the facade level. In fact, in ENVI-met, there are 7 types of temperature that can be simulated. Okay, what are the 7 types of temperature? One is general indoor temperature and outdoor temperature. Okay, for corresponding outdoor temperature, what is the indoor temperature that can be simulated? 1. What is the surface temperature of the building outside? Outside surface temperature of the facade, that can also be simulated. Surface temperature of the building inside, that can also be modeled. Okay, and in between, for example, let's say if you're using wall sections, if you want to know how much temperature reduction delta T has happened, because of this wall section, we can also do that exercise as well. Just too much. Yeah. Yeah. Vegetation again. Lot of things like I said, modeling can be done. So many aspects can be explored here, especially for landscape architects. This is the great tool where you can where you can play around and then model it in real time. Vegetation, we'll have a discussion later. What are the different types of vegetation inbuilt in the tool? We can also check, in addition to vegetation, we'll also be able to check what is the impact of green wall or what is the impact of water or mist system into the environment. Okay, so these are actually specific outputs or outputs that can be generated. In addition to this, the tool also generates something called the thermal comfort indices, especially PET, UTCI, ACT. All this can be generated. There is a special tool, or there is a not special, an additional tab called ENVI-met. Through this, we'll be able to generate these results directly. What is the UTCI for that particular state or cluster? What is PET, SET, all that. Yeah, so these are now already inbuilt that can be done. Now in the recent tools, in the no, it is there inbuilt already. Only thing is we should know these setups. We should be in a position to moderate clothing levels, activity level. So those input, if you are able to give, this will be more appropriate results. And of course, we can also bring in pollution data as well into the model to understand the realistic impact of how vehicle emission and other emissions contributes to heat or the vice versa as well. Okay, so there are two things that we should explore. One is ENVI-met info. Normally we go to envimet.com. ENVImet.com is where we have the tool. We'll do this after maybe 10 minutes break, but let me finish this theory part. So there are two websites. Please take a note. One is envimet.info. One is envimet.com. You will be able to download the softwares in envimet.com. We'll try to do that trial version from that website. But you have this ENVI-met info where you have the technical aspects of the tool. For example, let's say if you're not clear on any specific aspects of the tool. So where do we go? We go to envimet.info to get more information about the tool. So it has technical information about start, model architecture, application, e-libraries, and downloads as well. So under start, we have a lot of things. What are things, file formats required, and basic information about the tool. Under downloads, we have what is the recent version. In addition to that, we also have some worked out examples that can be directly downloaded into our system and then use. Okay, so that possibility is also there. We can take out examples and then check for ourselves. Then we have something called model architecture, where all the building physics or the algorithms that has gone into making of this tool, those information can be obtained here. Okay, and if you look at the actual application side, we have something. Once we open the application, we have something called headquarters. Now it is changed to some new name has been kept. We'll see that. So we have something called headquarters, where we try to set up the software itself. Okay, so this is the first tool, or first tab that we'll be using to set up where the files has to be stored, how the files has to be stored. This is the first step. Then we have something called a mode. Now it's not there as mode. Now they have directly used a tool direct link with QGIS and SketchUp model. Okay, so this is the second tool. The third tool is Leonardo, where visualization will be done. There's a tool called ENVI-met Core, where actually the actual simulation takes place. Then we have something called Spaces, where we do the model, and ENVI-met, where we generate specific urban climate indices like UTCI and so on. Okay, so this is what we'll be trying to see hands-on in coming days as well. In addition to that, we also have something called database manager, how to save the files and how to keep the data in a more compact way. This is also essential because one simulation of maybe 1 hour or 3 hours data, the output file will be of 3 GB, 8 GB, and so on. 24 hours data means it will be not less than 16 GB. So we should be careful to have which data, how much data is required. All that has to be checked. We have something called Albiro, where we can do vegetation model and ENVI guide for simulation setting, and climate related information will be able to give here in the forcing manager. We'll try to see that. Okay. Apart from that, there are other tools, tutorials you can check in. These are my own tutorials on this. If you have done in last couple of years, you can check that as well. Otherwise, the software also has a very detailed tutorial. We need not go to anybody XYZ for seeing how to use the tool. The website itself they have a channel in YouTube and they publish if there is a change in the tool, they publish what are the changes and how it has improved the overall tool. Okay, so that's it for from the theory part. Then we'll launch the tool, okay, and then see how it can what we can do with that. We'll have a break. Yeah, we'll just break for 5 minutes and then we'll do this. Yeah. And if there are any questions, you can.
Hello, sir. Hello.
Yeah.
Yeah, sir.
Discussing what ENVI-met.info. Yeah. We will get the information related to technical. Technical information. ENVI-met is a commercial website where software can be downloaded.
Hello. Hello.
इसके बाद आना तो कोई टेक्नीशियन होता है स्टार्ट ना ये देखो पहला तो स्टैंड होते पहला क्या बात क्या हो रहा है सर प्लीज कंटिन्यू या हां तो रिलीज वन वेट फॉर राइट गुड